Hello and welcome. I'm just back from a trip to Las Vegas for the Microsoft Excel World Championships. That's us on in the Wall Street Journal, sitting in the arena, which is pretty cool. Anyway, I am going to show you how to solve one of the cases from the championships. I'm going to do the one from the semi-final because I haven't completely wrapped my head around the finals one yet. That was pretty wild. This was called The Numbers Game by Andrew Grigalanovich, the founder of the tournament. So the idea is you've got a maze like this. It's 50 cells wide and 100 cells deep. And in every cell in the maze, you've got a number, but it's a number in hexadecimal. So you've got the digits 0 to 9, which mean the numbers 0 to 9, and then you've got A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. So it's the numbers 0 to 16, but just one digit each. And you have to answer various questions about them. They're all more or less independent from each other. So we've got 5 sort of standalone bonus questions, and then we've got 7 different levels, and for each one of the levels you have to answer, the same question but for various different inputs. So that's probably enough preamble. Let's just dive on in. So the first thing I did, and we'll do again now, because this was my semi-final case, was just name the maze MZ for maze, and then it's easier to work with it elsewhere. So the first bonus question is, how many numbers are stored as letters in the maze? So in other words, how many of these are A, B, C, D, E, or F, but not 0, 1, 2, 3, 4, 5, etc. So this is a relatively simple one. There's a few different ways you can do this. One is if you know the subtleties of the different count functions, then you can take advantage of the fact that count A counts both numbers and letters, whereas count only counts numbers. So if you want to get the number of letters, then you can get count A, which includes both the numbers and the letters, and subtract off the numbers, and that gives you that. Other ways you could do it, you could do sum of isText of MZ. So this will just return a true for any value that is text, i.e. the A to F, but a false for any value that's a number, and you can see the preview over there, false, false, true, da, 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 da. And then if we just multiply that by 1, or add 0 or anything like that, anything where you do math with trues and falses in Excel, it converts them into 1s and 0s. So that would give the same answer. Or the other option, you could say countifs MZ and just give it a list A, B, C, D, E, and F. And that will give you 6 different outputs. I put them across a row instead of down a column, so it's trying to spill, but anyway, you can wrap that in a sum. Lots of different ways to get the same answer. What is the sum of all the numbers in the maze when converted to decimal format? So this goes to kind of a big piece of this question, which is how do you convert these numbers from hexadecimal to decimal, because that's what we're going to need to do for most of these questions. So there's a few different ways you can do it. If you happen to know it, there is a hex to dec function in Excel. There's also, you can convert between hexadecimal, binary, octal, and decimal with native functions in Excel. So you can use, for example, hex to dec of B will give you 11. But hex to dec, I discovered, is one of those functions that does not like to work with an array. So hex to dec of that range throws an error. But like a lot of the functions that don't like to work with arrays, if you do something to the array first, then it'll work with it fine. So for example, if we concatenate a blank space onto it, which doesn't change the value, then it will behave nicely and spill out. So that is that. So what we can do in this case is sum of hex to dec of the whole maze and just concatenate a blank onto it, and that works out. If you didn't know that, there's various other ways you could do it. You could just build a lookup table that says, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, and then put the number beside them. And you can look up, you can do sort of bulk lookup, so you could still do this in one formula, just X lookup maze in the first column returning from the second column, and sum that up. That would work fine. What else could you do? I guess the other thing you could do is you could use code. So let me just grab a range of it here. So you'd say if is number, let's just take a subset like this. If that is a number, then give me the number. Otherwise, you can use code to get the Unicode character for letters. And then you can see you've got 66, 67, 68, 65. And so you just need to subtract off code of uppercase A and add back 1. add back 11 because so it's a minus a, sorry, no, add back 10. And then you would have a is 10, b is 11, c is 12, d is 13, e is 14, and somewhere, it looks like we don't have a 15 in this. Yeah, it says max 15, I don't see one. Anyway, lots of different ways you can do it is the point, so you don't have to know the hexadec function. All right, so what is the sum of all the numbers in the maze that are larger than 9 and provide your answer in hexadecimal format? So here we could do something like sum if is text maze, then give me hex to dec of maze and a blank, otherwise 0. Sum all those up, and then we need to convert that from decimal to hexadecimal because it says provide your answer in hexadecimal format. And that's all good. Just suppose that we didn't know about hex to dec and dec to hex, and you had done this by a lookup table. So let's say we get this number, and you want to convert that into hexadecimal without knowing the function. Well, you can do it from first principles as well. So you can say 116, 256, 4,000. So you can say, okay, so you've got here 23,000. That is less than 65,000, which is 16 to the power of 4. So you're going to have some number of 16 to the power of 3. So you could say that divided by that gives you 5.7. You can take the int of that, gives you 5. Then you can figure out the number you have left over, which is going to be this minus this times this, and that's 2,900. And then you can take that divided by that, and again take the int of that, and then you can take this minus this times this to figure out what you have left. That's 121. And divide that by that, and again take the int of that, and then finally figure out what you have left after that, which is 121 minus 16 times 7, and that gives you 9. And so you have 5. You can technically divide that by that, but obviously that just goes. So you have 5, 11, 7, 9, and then the 11 converts into a b, so you get 5b, 7, 9, just if you weren't able to do it that way. All right, and then the rest are linked to the cases down below, so let's dive on in. What is the sum of all the digits from 0 to 9 in the following rows? So here it's helpful to know that the sum function ignores text. So if you just hit sum on that, you get 106, which is the value for row 3, because sum ignores D and F and C and so on. So this is sort of easing us into it. The other thing to keep in mind is that the maze named range starts in the 3rd row. So the first row of the maze is the 3rd row of the grid. And that's basically all we need to know. So we're going to say, we're going to use choose rows of maze by this number over here, minus 2. And that'll give us the row of the maze, and then we just need to take the sum of that, and it'll automatically ignore the text. So that level's pretty easy. Let's look at level 2. What's the sum of all the digits from 0 to 9 in the following columns? So almost the same question, except that now instead of having a number that we can just reference directly in something like choose calls, we have a letter that we have to convert. So same basic idea, we're going to say sum of the column. The column is going to be choose calls from MZ, but now we have to find where does this letter happen. We can use the X match to do that. So we'll match this letter against all the headers, and you can just see, so that it's not giving it to me here. Let's come back. So that G84, we're going to preview that's S, and then if we match that against the headers, that will give 17. So we're going to take the 17th column, sum it up, and that solves that level nicely. Okay, so level 3, you're provided with a cell address. The cell is located in the middle of a square that has a side of 3 by 3 cells. You need to convert the hexadecimal numbers to decimal numbers and sum them all up. So here we can use a couple of controversial functions, which is indirect and offset. So if we say indirect, well actually first let's do this. AO14 is over here. It's that 5 there. Let's just highlight it so we can come back and get it in a second. So then if we reference that cell, it looks just like this, the name of the sheet, an exclamation mark, and then AO14. So indirect basically lets you reference a sheet range by a text reference. So this same thing gives you that cell as well, but then we can take this outside and make that a variable in the cell, just like that, and then that will reference the cell there. But what we want to reference is not just that cell, but the 3x3 box centered on that cell. And what we can do to get that is offset. So from that cell, we want to go back one row, back one column, -1, -1, and then take a range with height of 3 and width of 3. And that's going to give us 5, 5b, 2, 5e, 1, 1, 5. And if we go over here, just zoom in a little so you can see it better, you get, that's the exact box, 5, 5b, 2, 5e, 1, 1, 5. Okay, so then we're going to, same as before, we're going to hex to deck that, hex to deck of that, and again we'll just do that to it, and then we will sum that up. And that gives us 49, which should be right. Let's go check. Okay, so that's 3 levels. Let's look at level 4. On level 4, you're provided with a cell address. The cell has a value that is 9 or less. You start with 0 points and add the value of the initial cell to your running total. Moving from the initial cell to your right, add each cell's value to your running total. Stop when you first encounter a number that is more than 9. If you have not encountered such a number, then continue from the beginning of the next row. So in this example, we start at AY3. So let's just go there. So we start with 1, then we add a 2, then we've got to the end of the row, so we go to the start of the next row, and we hit a letter, so we stop. So our running total is just 1 plus 2. Let's try somewhere else. Let's say we start here, you get 5 plus 4 plus 8 plus 5 plus 0, and then you hit a letter, so you stop. I actually stuffed this one up a little bit. I mostly got away with it, but I missed the bit about wrapping around, so I thought you just went to the end of the row. I missed the bit about wrapping around if you get to the end. So knowing that it is that way, it's actually going to be easier to work with this if we unravel this first. So what we really want is just one big string that goes 0, 8d out to 1, 2, and then continues bd 3, 8, 1, 2 out to 4e5, and then continues again on the next row. And luckily Excel has a handy function for that, and it's called toCol, as in convert this two-dimensional range into a column. So we're going to just say, I don't even need to go over here, we're going to just say toCol of mz, and that gives 0, 8, d, 3, 2, and if we jump down, let's see, that's position 1, so if we jump down to the 50th position, that's the 1, 2 at the end of the row, and then bd 3, 8 should be the start of, the start of the second row. So that is the whole thing unraveled. So then we're going to say, is this going to be value? I guess we'll also want the address. So here we can say toCol of address of, so for address you need to give it, I make it, no, you know what, sorry, I was going to do it from first principles, but actually we've got the references here. So we've got the letters across here, so we'll just concatenate those with the numbers down here. And the nice thing about dynamic arrays is when you give it a row combined with a column, it automatically expands the row to be that many columns, expands the column to be that many rows. So actually, let me just do it outside the toCol first so that you can see what's happening. And then we'll toCol it so that it lines up. So this gives you all the C out to AZ3, C out to AZ4, and so on down to row 102. So then we're going to wrap that in toCol also, and that's going to give us a handy list of addresses that we can look up. So that's the address and the value. And let's see, I guess we'll do is number. And we'll just do is number of this. And just to make it easier to read, I'm going to multiply that by 1 to turn it into zeros and ones. I'm going to format it. You don't have to do this. It doesn't kind of change the answer, but just a number. Wait, what? Very confused. Oh, sorry, I put an extra semicolon in, that's why. Just a number format that blanks out the zeros, makes it easier to see what's going on. So here, that's your run. From here, that's your run. From here, you get these two. From here, you just get one, and so on. So then, I guess I'll do something like run size. In other words, how far can we run from here? So I'm going to say if this is equal to 0, then 0. Otherwise, we're going to see how far down we have to go to get to the next 0. So we're going to X match 0 against this. Now you can see because I've selected the whole column, it's automatically converted that into a dynamic array reference, but I actually don't want it to do that this time because I want the reference to move down. So I'm just going to select one more cell and then drop it back to 1. I'm going to put $1 on that. So what this is doing is it's fixing the bottom of the range, but it's having the top move down with it. So I'll show you what that does a little more clearly in a second. And by default, Xmatch searches first to last. So it'll, the first 0 it finds will be this one, or, if it searches from here, the first one it finds will be this one, and so on. And I think I might want a -1, but I'll check that in a second. Yeah, that 3 should be 2. So we'll say -1. And now let's just copy it down a bit. You can see that where there are zeros, it's just 0. But now what I was saying about the range expanding is now it's just pointing to the range from this cell all the way down, but still to 5001, so still going to the end. And so that just gives you the size of the run from each cell. And I'll just copy this format over here as well, so those zeros are easier to see. So in other words, if you start in C3, you're going to pick up 2 numbers. If you start in F3, you're going to pick up 2 numbers. If you start in M3, you're going to pick up 3 numbers. And I'm sure there's some bigger ones down here. So then we just need the run value, and that's going to be the sum of the next 2 numbers from here. And I guess let's just do decimal all in one place, so that's a little easier. So same as before, we'll go hexadec of this and a blank. So then the run value is going to be the sum of the first, in this case 2, but the first n here rows of that. And actually, sorry, I'm going to wrap it in if this is greater than 0, then it's the sum. And the way we get the first sort of n of that is we're going to take from this decimal column, and again, I don't want the dynamic array reference, so I'll just go down one more cell and then manually change it back into a 1. Lock that in. So we're going to say from the cell we're in down to the bottom, take the first, that number of rows, and sum them up. So here that gives 8, which is the 0 plus the 8. Here it gives 8 again, because you just get the 8. Here it gives 0. Sorry, I was about to say it gives 0, but it doesn't give 0 because I didn't say what to do if the if was false. So now it gives 0, and let's just copy this format as well. And we'll copy it down a little bit more. And so we can see here, it gives 0 plus 5 plus 4 is 9. Here it gives 5 plus 4 is 9, and so on down. So now we should just be able to do level 4 as a lookup. So we'll just do XLOOKUP of this address into the list of addresses, lock, returning from, that's F4 to lock, by the way, returning from the run value, F4 to lock. And that works. Hooray. And then there's also a bonus question linked to this, which asks, what's the maximum possible number of points you can collect under the level 4 rules? And that, because of the way we've done it, we have the run size from every starting position, so that's very easy. Okay, so that is 4 levels and 4 bonuses. Let's go on. 5, it gets a little more complicated, but nothing crazy. So on 5, you're going to read across one row. So you start off at a score of 0. You go to a particular row. So in this case, you go to row 3. And then you move right until you reach the end of the row. If the current number in the sequence is even, then that gets added to the total score. And if it's represented by a letter, A, C, or E, and even, then you get double it. You add it twice. If it's odd, then you subtract it. And if you try to go negative, you stop at 0. So 0 is the floor. And then you move on to the next number unless the current number is 0. And in that case, you skip the next 5 numbers and move to the 6th one. So let's kind of break this down. First thing is we're going to use choose rows just like before to get, so the third row of the sheet is the first row of the maze. So we're going to say that -2, and that'll give us this row. And then we want some function that will read across that row. So the first thing we're going to want to do is get rid of 0 and everything that comes within 5 of a 0. So how can we do that? Well, I'll show you without dynamic arrays first, and then we'll show you how to make it cool with dynamic arrays. So think of this, I'll just move it over here. So this is going to be the value, and this one I'll call it the exclusion count. And what I mean by that is when I get to a 0, I'm going to say, okay, jump up to 6, because then we'll have to exclude 5, 4, 3, 2, and 1. And then the next one we'll look at will be this one. And so then it'll go back to 0. And then here again, we'll hit 0. So we'll jump up to 6, 5, 4, 3, 2, 1. And that's how we'll, and then basically anything where the number is greater than 0 is going to be excluded. So how would we do that? We'd say if this is greater than 0, then this -1. So in other words, if we're in exclusion mode, then we're just counting down. Otherwise, if this is equal to 0, if the next value is equal to 0, then 6. Otherwise, stay at 0. And so that gives us 6, 5, 4, 3, 2, 1. Then we're back on for C. Then we come over as far as here. Then we're off again for 0. We carry on over here. Oops. And then we can kind of carry that all the way across. So then what you could do is filter values. And you could just say filter this where this equals 0. And then these are the numbers that you're actually interested in working with. So then decimals, we can say equals hex2dec of this and blank. And that converts them. And then we'll call it to add. And that will be, we'll say if is even this number, then we want to add it. And if it's formatted as a letter, then we want to add it twice. So we'll say that value times if is text that, then 2, otherwise 1. And if it's not even, then we want minus that. So that's the value to add, and then we need running total, and that's going to start at 0, and it's going to be max of this plus that. And wait, did I see a negative number there? I did. Oh, sorry, not max of this plus that, max of this plus that, and 0. In other words, don't go below 0. There we go. And that ends us up with a 2, which is what we're supposed to get, so that's good. And this is kind of a perfectly reasonable way to do it, and you could just change it so that this like see what this value becomes as you vary this value using a data table. And let me just show you that quickly. So the final output value is going to be, I'm going to use, so I don't want to just reference this cell, because then if there are more or fewer exclusions, the last cell won't be in that place. It'll move around. So to make sure it's dynamic, I'm going to say take from this. Oh, actually, that's not a dynamic array, so that's potentially problematic. Anyway, okay, I guess what we can do is xlookup true in, and then here we just need to make sure it goes out to 50 columns, because that's the biggest it could be. If there were no zeros and nothing was ever filtered out, then in that is not equal to blank. And so that'll just return true for everything where there is a value in there and false for everything where there's not. And then we want to return from that same array, so k to bh213. Oops, missed my. Return from there, and then the important thing is we want we want to search last first. So that'll look from the end. It'll say, it'll basically run through all the sort of falses over here where there's blank and get to here where there's something that's not blank, and then say true. So that will give you the number of this column. It'll give you the value in that column. So that's our 2, and then we're interested in, we want to know. Here we used 3, but what would that become? Actually, sorry, I'll just point directly to these. What would that become if we started with 69, with 5, with 55, and so on? And then the way that you can get Excel to tell you that is with a data table. So you can say my row input cell is, my column input cell, because this is the input that we're going to have from the column, is that, and we'll put each of these numbers into there and see what this number becomes. And there's no row input cell because there's nothing varying across the rows. So we hit OK. We calculate. It can sometimes take a second with a data table. I don't know why it's taking quite this many seconds, but anyway. And then hopefully these are the right answers. They're not, actually. That's interesting. Okay, well, I was hoping to show you the simple way to do it and then show you the more complicated way to do it, but I guess I've stuffed something up, so I probably just need to go straight to the more complicated way. I'm not totally sure what's going wrong here, but if I figure that out later, I'll put it in the video description down below. Anyway, what I really wanted to show you was how to do this all in kind of one dynamic array, because it's actually, in my view, easier to work with that. So what are we going to do? Well, we're going to basically build up the formula in steps. And the way to build up a formula in steps is to use let. So we're going to define things as we go along. So we'll say let row be this, that choose rows. Then we want that exclusion count. So we'll call it x count. And that is going to be scan. So scan is basically a way of making running totals like this. You build something up and then you apply some function to the accumulated value and the next input, and that gives you your next accumulated value, and keep going along like that. So here we're going to start from 0. We're going to scan across the row, and the function we want is, so A is what we've accumulated, V is the new value. So we're going to say if what we've accumulated is greater than 0, then that minus 1, otherwise if the current value is equal to 0, then we jump up to 6, otherwise 0. So that's exactly the same function here as we wrote up there, just using the names ac and val. So that's our scan, and then I want filter row where x count is 0. And let's just output that for a second. Didn't like that. Oh, sorry, because I used v instead of val. So where it's saying name error, it means it doesn't recognize some names, so you just have to scan where you've used names and see what's gone wrong. So that now gives me this same as here, CCBF6, etc., all the way out to ending in a 1, 2. Okay, so that's that, and then so then I want decimals will be hex to dec of all that stuff, and blank, and let's just return decimals for a second. That gives me this, my 12, 12, 11, etc. Then my to add is going to be similar to before. If is even dec, then dec times if, here we're just going to say if dec is greater than 9, because that's going to pick up those, the ones that are encoded as letters are the ones that are greater than 9. So if dec is greater than 9, then multiply by 2, otherwise multiply by 1. And if it's not even, in other words, if it's odd, then we want minus dec. So that's my to add, and then my running total is going to be, again, scan 0 and scan across the to add column, and the function we want is, again, I'll just call it ac and val again, and it's going to be the max of ac val, sorry, ac plus val, and 0. Enter 2, oh sorry, yeah, so I've defined the last variable, and then I need to tell it which thing to output. So in this case, we're going to output run top. And you can see this now matches my 24 to 24, 48 to 48, 37 to 37, etc. Matches this whole thing there. And then I can just say take from run tot, comma, minus 1. And that gives me my 2. So I'll take that, put it over here, and point it down to this value. And that gives me 66 instead of this one giving me 62, which I'm kind of confused by. Maybe I referred to this in more than one place. No, that's a different one. So if I put in 69 here, that gives me 62. This one gave me 66. I don't know why they're different. Ah, there it is. It's because I was conscious at one point that I needed to allow for the possibility that it might go out to 50, but here, where I didn't have a dynamic array, I had not copied it out. So in this case, the values actually go out further. So I'd need to make some more adjustments to make that work. So anyway, that's the benefit of working with dynamic arrays, is that you don't have to worry about things expanding and not expanding and matching and not matching and so on. Anyway, obviously if you write it in a non-dynamic array to start, then that's fine. And you might find it easier to just do workarounds to allow for the size changing. But once you get used to it, writing it straight as a dynamic array like this is actually is actually pretty simple. So now, the nice advantage of doing it this way is that when we, oh, this one's wrong. I have a vague memory that, hey, I got this one wrong when I tried it yesterday as well. Okay, so let's just see if we can see what's going on here. So I'm just going to name that output, and then I'm going to output some checks instead. Oh, yeah, I remember this. I remember exactly what went wrong. And it is this logic here, which is if, let's bring back my workings. So if you remember this exclusion count, oops. So what the heck, this was 3 before. So let me put that back. So if you remember this exclusion count went 6, 5, 4, 3, 2, 1, and then started again from here. But here the previous value is 1. If the new value is 0 here, then I need to jump back up to 6. So my logic was not quite right here. I said if this was greater than 0, then take that minus 1. I should have actually said if that was greater than 1. Because if it's 1, then this is back on. So we want to go ahead. So that's the slight wobble that I made there. So this should say if ACK is greater than 1. And if I copy that down, yeah, now I get that one right. Okay, so then let's come down to level 6. So this is a 2-player game, mostly the same as the previous level, but the second player plays with reversed rules. So they go from right to left across the row. They add odd numbers, still double them if they're represented by letters. In other words, if they're greater than 9, and they subtract even numbers, and all the other rules are the same. So first of all, let's just work out player 1's score exactly as before. So that's going to be, all we have to do is update this reference to here. And that's 177, so I guess player 1 wins. So we'll just label that P1 score, and we'll call this P2 score. And then we just have to take this and modify it a little. So how do we modify it first? We move the reference across, so we get player 2's row. Then we need to reverse that row. So how are we going to do that? Well, one way we can do it is sort by. What we want to do is sort by a sequence that is in reverse order. And one way to get that is to say sequence. We don't want any rows, or just one row, but leave blank for default. Columns, we want the number of columns in the maze. And then you can either just wrap it like that and just put a minus sign in front of it. So you get -1, -2, -3, -4. So when you sort them in order, they flip the other way around. Or you can take them in steps of -1. Either works fine. So that'll reverse the row. And then the exclusion count is the same. Converting to decimal is the same. And then what we need to add, just instead of testing for evenness, we test for oddness. And then this part stays the same. So if it's odd, then we add it. And if it's greater than 9, then we also double it. And if it's not odd, then we subtract it. And all the rest stays the same. So that's that. Then we copy that, put it down. And then for each row, we just want to take the higher of the 2 scores and fill that down. And that is how to do the first 6 levels. I'm conscious this video has gone on a little bit long, and the 7th level is, and the 7th level also relates to the last bonus, is pretty tricky. So I'm not going to try to add that onto this video. I might do a separate video on it later. I'll just quickly tell you the idea in case you want to try to play with it yourself. So the idea is that you want to consider regions in the maze, and so the sort of walls of the regions are the numbers. And then the contents of the regions are the letters. So let's just, we'll probably do a quick conditional formatting here to say equals is number of C3, then format and make it black. Okay, okay, okay. And so now you can see that, so anywhere where there's even a corner connection, that is a region. So this is one region here. Those 3, that one and that one. This is one region here. So you have to answer various questions about the sizes. So first you want to know about the regions, the size of the regions containing certain cells. So where did that land us? In 27. Oh, sorry, I'm behind my face. So here, for example, this region is of size, whatever that count is, 10. Let's test if that's working. No, sorry. We want to sum the numbers in the region. So anyway, that's going to be a little bit more complicated. And then for the bonus question, we have to figure out how many regions are there in total, which by the time you zoom out to the whole scale of the map, that's going to be quite a thing. So we're going to either need some funky formulas or some circular references or something to make that happen. So like I said, probably a little bit much to take on for the length the video already is, so I'll do that another day. That's what I got for today. Thanks for watching. See you next time. Okay, so my last video I was tackling this challenge, the numbers game from the Excel World Championships semi-final, and I had done all the levels except the last one, which I figured was too long to add on to an already long video. So let's take a look at that now. I explained it quickly on the last one. So the idea is we have a bunch of numbers and letters in here. We treat the letters as open space, and we treat the numbers as walls. So areas are connected if there's a diagonal or a direct edge connection. So for example, this, all of this, all of this, all of this, all of this is all connected in one big region. Don't see where it is, so it goes out at least as far as here, all around here, all around here, all around here. Yeah, it ends up being very big. So the question was to figure out A, for a given cell, sum up the value of all the numbers in that region, and B, to figure out how many regions there are in total. So I'm going to try a sort of circular reference approach. Call this regions. I'm not 100% sure. I tried this on the day and I couldn't get it to work. So I'm just going to fill in X's around the edge. I'm going to use X to represent a cell that is not passable. And then I'm going to go here. Do I want to do this? Yeah, I'm going to go Control G, Alt S for go to special. I'm going to go to constants and I'm going to select just the numbers, not the text. And once it's got all those, it's taking, oh, wait, what? That is taking way too long. Okay, my Excel seems to be crashing. That's not good. All right, better give it a second. Okay, so that didn't work quite as I was hoping to, so let's just do it a different way. So what I'm going to do is I'm going to do formulas with circular references. So the first thing I need to do is go Tools, Options, Formulas. Well, I've already done it. Enable iterative calculations. Then the second thing you need to do is have a circuit breaker. So I'm just going to say circs question mark, and I'm going to put false here for now. Then I'm going to say if is number this cell. So if the corresponding cell in the maze is a number, then I want X because you can't be there. Otherwise, I want the minimum. No, let's take the maximum of the surrounding values, and this formula spelling out the way it is. So sorry, try that again. The maximum of that, and this one below. And then I just need some value for this location itself, which can be let's say row times 1000 plus column. So the idea here is I'm just that one's a number, so that's no use to me. But if I come down here, I got to get rid of the conditional formatting. That's highlighting all the numbers. Clear that. So now this is 4003, meaning it's in row 4 and column 3. But then if I expand to another letter next to it, they're now both picking up 5003, because this is picking up 5003 from itself, and this is taking the max, sorry, this is picking up 5003 from itself. This is taking the max of its own value, which is 4003, and the 8 surrounding values, so it ends up with the same value. So now let's see if we can expand this. So now the last cell in this range is 6003, so that the whole range is taking on that name. Oops, need to widen this out so that we can actually see them. And that seems to be working, so let's expand it to the whole range. And Control Enter. And that seems to be working absolutely fine. So then first I need to figure out what region this is in. So we're going to say indirect regions, exclamation mark, and that. That points me to this cell AN27 on the regions tab. And that tells me that the value in this region is 59,046, which makes sense, I guess, if this somehow connects all the way down to row 59. Okay, big region. So then what I want is, I want to say sum of if, I guess I gave the thing the named range MZ, so there should be a regions version of MZ. So if that is equal to this value, then I want the hex2dec of my maze and blank, otherwise 0, and sum it up. And that seems to be working. So then we can just take this part and put it inside the formula so that it'll copy down. So that works very nicely. And then for the bonus question linked to that, I'm going to say how many unique separate regions are there in the maze. So I'm just going to say unique of tucol of regions maze, and all of these except the x are a value. So what I want is the rows of that minus 1. Rows of that minus 1. And let's see if that is the right answer. I think I remember 129. That looks promising. There we go. So that, along with the other ones I did before, gets us to 2000, which is the full score for that level. All right, that's all I got for today. Thanks for watching. See you next time.